Greetings to you, beautiful people. You are welcome back to my channels. Have you ever wondered what an impurity could cause to a product? The effect it could have on the product, how it can be characterized. Today's topic, we are going to be talking about impurity. Our topic today is impurity and purity, chemical purity and purity. My name is Rahma Idris from Chemistry Extensive channel. If you like what I'm doing on my channel, please do subscribe to my channel. Give it a thumbs up, share with your friend, press the like button, and do give it some comments so that you encourage me to do more better. Thank you. Let's go into today's topic. Greetings to you, beautiful people. You are welcome back to the class. Today we'll be having chemical purity and impurity. So what we are going to discuss is chemical purity stroke impurity. So chemical purity is referred to the degree to which a chemical or drug substances is free from impurities or contaminants. In other words, it means the proportion of desired compound relative to any other substance present in the sample. Chemical purity is a critical aspect of various critical aspects of various industries, including pharmaceutical industry, chemical industry, electronics, food industry, where the presence of impurity can affect the safety, efficacy, and quality of products. Here are some key points about chemical purity. Chemical purity is typically expressed as percentage or a fraction representing the ratio of the desired compound to the total mass of the sample. For example, a chemical with 77% purity means that 99% of the sample consists of desired compound, while the remaining 1% comprises of impurities. Impurities are chemical substances that are derived from the chemical composition of material found inside amount of liquid, gas, or solid. They differ from chemical composition of material or compound. So now, any compound that is considered to be pure has to have one of the following or some of the following. It must appear in at least one chemical phase. It must be homogeneous, i.e., it must have uniform substance that has the same composition throughout the material. It should not contain any trace of any other kind of chemical species. In reality, there are no absolutely 100% pure chemical compound, as there is always some small or trace amount of contaminant. Impurities in chemical substances can arise from various sources, including, so we're going to talk about types of impurity now. These are going to include related substances, so compound forming during synthesis or degradation process, such as intermediate, byproduct, degradation product, chiral. Those can be related substance impurity. We also have residual solvent. Residual solvent can occur from volatile organic compound used in manufacturing process that may remain in the final product. Also, inorganic impurity. We also have inorganic impurities, which include metal, catalysts, and inorganic material introduced during synthesis or processing. Other impurity include environmental contaminants, such as substance present in the environment that may inadvertently contaminate the sample during handling or storage. Also, organic impurities is another example of impurity. Microbial can be an impurity, and storage and packaging related impurities can also be types of impurity. So analytical techniques used to determine the impurity of a chemical substance, including the chromatography, high performance liquid chromatography HPLC, gas chromatography GC, and thin layer chromatography are commonly used for separation and quantifying components in a mixture. So this is column chromatography image. Spectroscopy is another instrumentation that can be used to characterize impurities. Spectroscopy techniques such as UV visible spectroscopy, infrared spectroscopy, and nuclear magnetic resonance spectroscopy. These can be used to characterize impurity. It provides information about chemical composition and structure. So once the original structure is known, impurity can easily be detected. So this is the image of a typical spectroscopy. So mass spectroscopy. Mass spectroscopy is another technique that can be used to characterize impurity. These include LCMS, liquid chromatography mass spectroscopy, gas chromatography mass spectroscopy, GCMS, are used to identify and quantify compound based on their masses to charge ratios. So titration is another method for characterization of impurity. The titration methods such as acid-base titration are used to determine the concentration of specific substance in a solution based on the chemical reaction with a known titrant. So other titration can include acid-base titration, precipitation titration, complex formation titration, and oxidation reduction titration, redox titration. So there are common industry standard method for specific type of impurity. This can include the use of HLGC, air-space gas chromatography, and FID, flame ionization detection, or mass spectroscopy for analyzing impurity of residual solvent and volatile organic impurity. Also, HPLC, MS, or NMR can be used to analyze non-volatile organic impurity. More so, ICP OES or ICP-MS, which is inductively coupled plasma optical emission spectrometry, can be used to analyze inorganic and elemental impurities that can arise from elements. Effects of impurities. Why do we care so much about the impurity? What is the disadvantage? What can it cost us if we have impurity in our chemical or drug? Impurity can have significant negative consequences for our products during drug development and beyond. They can complicate formulation, lengthen the development timeline, and also impact shelf life due to growth of degradation products. So they can affect the shelf life of the drug or chemical. Impurities, even at a very low level, may pose unknown health risk to patients who use the final pharmaceutical product. So it is far better to detect, identify, and control impurity as early as possible. Identification of impurity formation early in development can avoid complication at later and more costly stage. Specific steps include, so for us to be able to avoid impurity that can cost us later complication, the following steps should be taken. The evaluating starting material impurity. Evaluating starting material purity. So, minimizing impurity level in synthesis and manufacturing processes. Identifying impurity structure. So when we identify our expected product structure, impurity can easily be identified. So isolating and synthesizing impurity for qualification in toxicity studies. Monitoring the stability of API, active pharmaceutical ingredient, and DPs, drug products, to detect degradation products. Liquid chromatography mass spectroscopy and HPLC performed liquid chromatography can be used to obtain mass spectrum of each impurity of interest. A liquid chromatography high resolution mass spectroscopy experiment can quickly obtain information on each impurity. So next is analytical and process chemists work together to screen high resolution mass spectrometry software matching to narrow down the number of meaningful structure related to reaction. The fast and agile approach typically significantly reduce the number of suspected structure. So to further confirm the impurity structure, isolation of impurity via preparative high performance liquid chromatography or supercritical fluid chromatography will be performed to obtain sufficient quantity of the impurity for NMR analysis. These results and the proposed impurity structure are often cross-checked by synthesizing the potential impurity using orthogonal structure confirmation. This increases the confidence of the proposed impurity structure, and it's often required as part of the drug application filing. Gram scale synthesis of each impurity may then occur if required for good laboratory practices. Toxicity qualification. For good laboratory practices, toxicity qualification. So storage and stability analysis is another measure that can be used. Storage and stability analysis are very important part of the overall impurity control strategy. So it's a great, after taking special precaution from beginning, the final package have to be well taken care of to avoid contaminant due to storage of the products. Thank you. This brings us to the end of the class for this class. You can comment below if there is any aspect you want me to touch more, so that I can make a video that will talk about it. Thank you. Stay blessed. Please do subscribe to my channel. Give the video thumbs up. Share with your friend. And please comment on whatever you want me to discuss more. Thank you.